Assalamu alaikum warahmatullahi wabarakatuh. MATLAB course. This is the fall 2021 homework number 1, exercise number 2. In this exercise, write a continuous program that asks user to enter an integer n. The program should verify that n is greater than or equal to 15. Then it prompts user to select one of the following options. I will keep the continuous program to the end, so I will start from here. Ask user to enter an integer, then verify that the integer is which is n should be greater than or equal to 15, and then show a message if it is not equal or greater than 15. I will show a message and read again. So I will start new script as usual, CLC, and clear, and then close all, and then a comment, ask user to enter a number, an integer, and this integer should be greater than or equal to 15. Then go to next line like this. Sorry, this is just a comment. Here we have to say that n equal to input. I'm using the function called input to show a message, and at the same time I will read the keyboard value entered by user. So please enter an integer, and this integer should be greater than, say that it is n, and this n should be greater than or equal to 15, greater or equal to 15. And then now I will check if the user entered a number which is n, if this n not greater than or equal, say that less than 15. Okay, in this case what should I do? I should again, if n less than 15, I should ask user to enter n again. So we can repeat this message, Ctrl C, Ctrl V, and say that please re-enter an integer. It should be greater than or equal to 15. Make the message clear, and then go to next line, here, and same thing here. But the problem, if I run the program now, it will show question number 2. Okay, it will show the message just once. If there is if the number entered again wrong number, it will read it at the first time as a wrong number, because we used F here. I will show you. Run the program. See, please enter an integer, say n equal or greater than 15. This is 14. This is 14 again. It will accept 14 and then exit. And this is not okay. Why? Because I'm using F. Instead I will write while n less than 15. Do this one. Keep doing this one. Run the program. See the difference now. This is 14, 14 again, 14 again, 14 again. Now 15. Acceptable. We did the first part. Next part. Then it prompts user to enter or select one of the following: E as a character to print all odd numbers from 1 to n entered by user before, that divisible by 3. So I will ask user to select or choose. So choose, we can say that choose or select anything. Say that selection variable s equal to, I will input a message and ask user to enter the following. We can say that please enter, then go to next line, 1 2 spaces, then write for the first one it is E. We can show as example character E like this, E as a character. Okay, enter E, can say E like this. Okay, E to print all odd numbers divided by 3. Control C, Control V, like this. E to print all odd numbers. Say that odd numbers 1 to n. You can just simplify the message. 1 to n divisible by 3, then go to next line. Okay, we can actually use one line, no problem, but let me make it the spaces less than before. It's okay. Next option, one space only, enter. We can repeat this one, or we can say that O like this. Control C, this is the second option. Okay, but delete this one. Okay, and here put the quotation here instead. O to print even numbers. We can say that 1 to n divisible by 5 and 6. Then go to next line. And the last option here, P. Control C. We can say here, go to next line, then Control V. Enter P to check if n is a perfect number or not. And the last option here, enter X to end the program. Control C, and here go to next line, and Control V, X to end the program, and then Control or backslash n to go to next line. And last thing, don't show me the result here, like this. Okay, now let me check the code, run the program, enter 15 as example. C, please enter E to print, O to print, P to check, X to end, and so on. Control C. Let me just write double dot here. Control C, and where is it? Yes, here, like this, better. Okay, now if the user enter E, we want to print odd numbers from 1 to n that divisible by 3, the odd numbers, only odd numbers. So how we can do that? Okay, now we have n, which is an integer entered by user. So let me say that we have all numbers an equal from 1 to n, incremented by 1. So these are all numbers from 1 to n, just in one vector called an. Then I want to check or print just the odd numbers from 1 to n that divisible by 3. We can use logic statements. We can use, as example, for loop. I will select for loop. Say that I have a loop from 1 to say that n. Okay, this is the end of the loop. What I will do in this loop, actually I will check if, say, we said now odd numbers. We need the odd numbers first. Okay, and these odd numbers should be divisible by 3. If it divisible by 3, print it. So how we can first find the odd numbers? If you remember the logic statements, we can say that I want odd numbers equal an when modulus of an equal to 1. Now if you remember, modulus of an equal to 1, that means these are all the odd numbers. When the first element in an, which is 1, modulus, we forgot modulus to 2. When the first element of an, which is 1, modulus to 2, it is 1. Is it equal to 1? Yes. That means this number, it is what? An odd number. So for the first number, this statement will return 1, which is true. If the an of true, that means take this element and save it on on odd numbers. And same thing for even numbers. If you want it, write even numbers equal, same idea, Control C, Control V. You can say that an, when modulus an to 2 equal to 0. So for I equal 1 to length, in this case, length of what? I'm working on odd numbers in the first part. Length of odd numbers, because I don't know how many numbers inside the odd numbers here. It could be 100, could be 50, it depends. So just the length of on. Check now if the odd number inside on, is it or it is divisible by 3. How we can say divisible by 3? If modulus of this, now if modulus of this on of I, this element in on, it depends on I. When I equal to 1, take the first element of the odd numbers, check the modulus to 3. If the modulus of this number to 3 equal to 0, that means it is divisible by 3. I will show you in the command window here what is that. CLC. Let me define n, or let me define an. All numbers, say that from 1 to 10 only, from 1 to 10. Don't show me the result. Okay, this is the an values. Now I will say that on odd numbers equal an, the an, when the modulus of an to 2 equal to 1. See, I will take the first element in an. It is 1. 1 modulus to 2, it is 1. Take it and save it in on. Then take next number 2. 2 modulus to 2, it's 0. False. Don't take it. True. Take it. False. Don't take it. 5. True. Take it. 6. False. Don't take it. 7. True. Take it. 8. False. 9. True. Take it. 10. False. Don't take it. Same thing for the, I will repeat, but for the even numbers. So we can say that this is en, even numbers, equal n when modulus to 2 equal to 2. We will get en equal an, modulus of an to 2 equal to, sorry, not to 2, it should be equal to 0. I'm sorry for that. The modulus to 0 will be even numbers. As you see, 2, 4, 6, 8, 10. So now we have en and we have on. So let me show you the odd numbers. These are the odd numbers. Now I will show you. I will write on. I will write modulus of on to 3. See, 1 modulus to 3, it is 1. So 1, it is not divisible by 3. 3 modulus to 3, it is 0. 3 divisible by 3. 5 modulus to 3, 2, not divisible. 7 is 1, not divisible. 9 modulus to 3 is 0, but 9, it is divisible by 3. So this is why I wrote the algorithm here. If modulus of on to I, if modulus of on to 3, sorry, modulus of like this, okay, equal to 0, In this case I will print. I'll use F or display, it's up to you. F print F. We can say that print. I will reserve a space for integer with -5 places to the left. Then write one space like this. Okay. For this F we need end. This is the end. This is the end. Save. Run the program. I will show you. I will choose n 20 as example. I will write E here now. E here. Wrong. E should be a character. I will run again. Control C. So say 20. I will write a choice like E, like this. But I don't have the result here. Why we don't have a result? We choose E to print odd numbers 1 to n divisible by 3. So I forgot, yes, to print a number here. Which number? We reserve the space for integer. Which integer? It is on of this I when this condition is true. Run the program again. This is 20 and this is E. Sorry for that again. This is E. Okay, see 3, 9, 15. These are the odd numbers that divisible by 3, but the message, a clear message, should be displayed before this one to show what this result. So I prefer, before this loop, I prefer to print a message. So I will copy this one, Control C, Control V, and same thing here. We have to add a comment. I forgot to tell you about comments. You should comment here what you are doing here and what you are doing here. Okay. As you see here, we want to print a message. We can remove this variable. No need, because I'm not showing a variable value. I'm showing a message that all numbers between, or all numbers 1 to this n, which is say integer, okay, that divisible by 3 are, then go to next line, go to next line. Before that you can write double dot, all numbers 1 to d that divisible by, sorry for that, by 3 are these numbers. Okay, from where I will get this number? It is n, entered by user. So this should be n, like this. Now again run the program, say n is 20. Now I will enter the E. We can change E to number, but in the question says that enter E O P X. See, all numbers from 1 to 20 that divisible by 3 are these numbers, and then we should print \n to go to next line better. So I will if print like this, Control C. After the loop here, just go to next line, \n better, like this, guys, to show this sign after the numbers better. And I prefer to go here and add just one space, 2 spaces, 3 spaces, like this better. Okay. Or if you don't want to add spaces, I will show you. We can remove the minus. Minus, it means print the number to the left of the space, make it to the right of the space, and increase it to 6, like this, guys. Run the program. This is 20 and this is E, this is E, and this is the result. Next step, we want to enter, if the user enter O, we want to print all even numbers from 1 to n divisible by 5 and 6. We will repeat the same thing. It's very easy in this step. What we will do now, I will print comment first, tell what to do, and then I will go to here. I will show message, then this one, and then this one. Same. Control C, Control V. All numbers from 1 to n that divisible by I'm sorry, this all odd numbers, I forgot that, and here all even numbers from 1 to n that divisible by, I'll see here, by 5 and 6. We can write 5 and 6 like this are. Now same thing, but here we'll choose not odd numbers, we'll take even numbers. Remember that we define it here in line number 13. We have en modulus of en of I to 3 equal to 5 at the same time, and by the way, this should be as you said, 5 and 6, 5, and I will repeat same thing for 6. Okay, if modulus of en of I to 5 equal to 0, and at the same time modulus of en of I to 6 equal to 0, that means divisible by 5 and 6. In this case, print this number, which is even number of I. That's it. Run the program. Say that we have just 20 numbers in 20, and now I will enter the option O like this. Enter. See, all odd numbers. Actually, I will let you know how we can fix this one, but never mind the all odd numbers. All even numbers, we didn't fix it or not. There are no numbers between 1 and 20 that divisible by 5 and 6 together. Let me try another number. Say that we have 100, n is 100, and we need the option O, like this. Yes, now we have all even numbers between 1 and 100 that divisible by 5 and 6. They are 30, 69. Okay, but this is for the odd numbers. But we should not show the two results. It depends on the user. It depends on the user selection. But here we did the first part and second part, okay, without seeing what the user selected. So we have to ask user to enter A, S, or whatever. Now according to the entered value, we should do this. So what I will do now, I will copy all of these. I will copy or cut all of these. So not from here to here, these options. Okay, cut or keep it like this. But I will write switch statement. Switch. I will switch on the value of S. It depends on the value of S. Okay, we have case that the value is equal to what? Equal to E, like this. What I will do, I will do the following. I will print this message. Then for the for loop, this is inside, this is for the end, this is for the for loop, and I will write here. Then go to next line. Yes, like this. Now the case that the value of the S equal to O, equal to O, like this. We can do the following. So we have to align it correctly like this. This is the for loop, this is inside for loop, this is inside if, this is the end, this is the end of the for loop, this is with the for loop, like this, and enter. This is the end of the switch statement. So this is case E and this is case O. If you want to make it E capital or E small, we can add them like this. You have two cases, E capital or E small. And same thing here, guys. We can make two cases in one. So if it's O capital or O small, like this. So we have two cases here. Save the program. I will show you the result. Run the program. I will enter 100, but in this case I will enter O small. Problem, because O small, it is not a variable name, should be a character, so I will enter it as a character, as a O small. See, all even numbers from 1 to 100 that divisible by 5 and 6 are 30, 60, 90. Good. Next case, P, to check if n is perfect number or not. So again, here we have case E, case O, and now we will write another case. Okay, this is case that the value of s equal to, as you see, it is P or P capital or P small, sorry. So I will copy this one, I will paste it here and write P capital or P small. Okay, now what we will do, we want to check if n entered by user is a perfect number or not. What is the perfect number? A perfect number, a number considered as a perfect number if sum of its divisors except itself equal to the same number. Example, for example, we have 6. I want to test 6, is it a perfect number or not? Let us see what are the divisors. Now 6 divisible by 1, yes. 6 divided by 2, 6 by 3, and 6 by itself, but the itself will be excluded. So as you see, for 6 itself, the divisors are 1, 2, 3, 6. Exclude 6. Now the 1 and 2 and 3, add them together, the result is 6. 6 equal the number itself, yes. So it is a perfect number. So as you see, here it is the 6. What are the positive factors? They are 1 and 2 and 3 and 6. Exclude 6. 1 plus 2 is 3. 3 plus 3 is 6. Now the sum of all factors excluding itself are 6. 6 equal to the number itself? Yes. So it is perfect number. It is a perfect number. So we need to check if n is a perfect number or not, the n entered by user. So as you see here, we will first of all, we want to save the factors in a vector, say f. So I need a loop to go from I equal to 1 to that number itself. Okay, this is the end of the for loop. Now I will check if modulus of the number itself to that I, if this modulus equal to 0, that means n is divisible by I. That means I, it's a factor of n. Okay, but at the same time, this I should not be equal. Should not be equal. Should not be equal to the number itself. In this case, this is the end of the if statement. In this case, say that factor of I, of j. We need another counter because I here will count from 1 to n. Okay, if this is true, I want to save it as an element inside f. So I need a counter j for this f, and j should start from 1. So here in this case, before, we can say that j equal to 1 by default. Initial value of j is 1. If this is true, then f, the first element of f equal to I. Okay, and when you go to here, before ending the f, say j equal j plus 1. So again, now I equal to 1. Is 1 modulus 1 to I, modulus n to I equal 0? If yes, that means n divisible by I. Is this I equal to n, not equal to n? If yes, if this one yes and this one yes, save I in the f according to the j counter. So for the first one, j will be 1, then j will become 2, then go here, n equal 2. Is 2 modulus n to 2 equal to 0? If yes, and at the same time I not equal to n, if yes, f of j, remember that j last value is 2, f of 2 equal this one, and so on, guys. So this is why I wrote here j, not I, because I, it's a counter from 1 to n. Not all of i's will be used for f, just when this condition is true. So I want to use a counter for f. Say this counter is j, and don't forget to increment the counter before go to next I. Now when this loop finished, it contains or give us a vector called f, and f contains all numbers, all factors of this n except the n itself. Now we have the factors. Now I will check. Now we finish this loop. I will check here if the n itself equal to sum, or yes, sum of factors. If this is true, that means what? This is the end of the f, by the way. I will print f, saying that this number, it is a perfect number. This number, it is a perfect number. So we can say that this number, which is integer, okay, space, sorry, is a perfect number. Then go to next line, from where I will get this number. It is the n value. Remember that this is the case p or p small, start j from 1. J, it's a counter of factors. Okay, I, it's a counter for the factors of n. So 1, then 2, then 3 until reach n, and we will test I value each time. Is it a factor or not, using this algorithm. That's it. Save. Now let me run the program. Now say that I have 20. Now is 20 perfect number? I don't know. Say that I will choose the option, the p option, p small or p capital, doesn't matter. Nothing happened because we don't have else, because 20 is not a perfect number. So what I will do, I will add else here. Else, if this is not true, if n not equal to the sum of f, that means it is not a perfect number. Just I will show one message like this: it is not a perfect number. Run the program again. Say this is 20. Remember that n is 20 now. The option here, it is p. As you see, 20 is not a perfect number. Run the program. Let me select 22, and this option, which is all even numbers. Run the program. Say we have 100. Okay, and this is the p. This is the p option, perfect number, not a perfect number. I don't know. I can't remember which number from 100 is perfect number. 6, but 6, it is outside the range. 6 less than 15. So let me just to check the algorithm, let me say that here if less than 5. I will figure it out later or fix it later. Just run the program to test the last algorithm. Say this is 6. Now I will enter this option, which is P. It should say that 6 is a perfect number, which is correct. But remember that 6, it is outside the range. We have to enter a number, and this number should be greater than 15. So I will go back to here, say while n greater than 50, less than 15, repeat to enter the number again. So I finished this part. The last part here, x to end the program. Why we wrote x to end the program? Because it should be continuous program. How we can make it continuous program? So our program from here to the end, as you see, I will cut all of this code, then write here while 1 for a continuous loop. This is the end of the while loop. Okay, and here we can paste our code. Okay, now we will add the last case P. We finished it. Where is the this is the end of the case here. I'm not sure. This is for the switch. Yes, so this is the end of the case. So let me write a case here. Case that the value entered by user, it is E small or E capital, as example, or E capital. Sorry, this is E small and this is E capital. In this case, just break. It means break the for loop or the while loop. That's it. So this is for the case. Yes, good, like this, and remove the spaces. Align them correctly. Yes, like this. Run the program. I will show you. Please enter. This is 20. Sorry, it should be X, not E. I'm sorry for that. Control C. I will go back to here. It should be X, not E, because E is the first option. This should be X capital. Save it. Run the program again. This is 20 as example. This is the option X. It will exit. Better to show a message before exit that you selected X. So case X here before break. Let us show a message f print f you selected to exit the program. Then go to next line like this and write end. Go to next line and then break. Run the program. Let us check the result again. This is 20. This is the option which is X. You selected to exit the program, and if you wish you can remove the space before the end like this and keep it like this. Okay, so as you see, this is a complete program. While 1, this is the end of the while loop. To make it continuous program, how we exit from the program when the user selected or entered X small or X capital, and these are the cases. I hope that everything understood and clear. If you have anything, you can just write a comment on YouTube. Thank you so much.